This is Math 83, Unit 3, Lesson 6. We're going to square a binomial, and then we're going to simplify and write in descending order. Well, x plus 6 all squared means x plus 6 times x plus 6. So we're going to write that out twice, and then we're going to go ahead and use FOIL. So x times x is x squared, x times 6 is 6x, 6 times x is 6x, and 6 times 6 is 36. And then we combine like terms. Our middle terms here, 6x and 6x can combine. So we're going to rewrite this as x squared plus 12x plus 36. Now, one of the most common mistakes that I see students make is that they want to square everything that's inside. So here is the mistake that I always see. X plus 6 all squared. A lot of times I see students wanting to apply the square to each one and do x squared plus 36. Well, we can't do that because what's inside of the parentheses is a sum. And the only time we can apply that law of exponents is when it's a product or a quotient inside of the parentheses. Here is when it's okay to do it. If I have something like 6 times x, because this is a product, that I can square each one and get 36x squared. Or if I were to have a quotient like 6 over x squared, there I would get 36 over x squared. But anytime we have a sum or a difference, we're going to have to write it out twice, and we're going to FOIL. Now go ahead and do numbers 2, 3, and 4 on your own, and then come back and check your answers. Now check your answers for numbers 2, 3, and 4. Now we'll do numbers 5 and 6 together. We're going to take 2x plus 6 and write it out twice. And we'll go ahead and FOIL. 2x times 2x is 4x squared. 2x times 6 is 12x. 6 times 2x is 12x. And 6 times 6 is 36. We'll go ahead and combine like terms here in the middle and get 4x squared plus 24x plus 36. We'll go ahead and write this out twice. 8x minus 2y times 8x minus 2y. We're going to FOIL. 8x times 8x is 64x squared. 8x times minus 2y is going to be minus 16xy. Then these inner terms together also give us a minus 16xy. Last terms plus 4y squared. So the middle terms again are the ones that combine, and we rewrite this as 64x squared minus 32xy plus 4y squared. Now we're going to apply the distribution rule to multiply the sum and difference of two terms, and then we'll simplify and write in descending order. This is done exactly the same way, but I want you to notice that both of these terms look a lot alike. The only difference is this one has a plus and this one has a minus. But the variable and the numbers look the same. Over here, the same thing. 5x and 5x are the same, 6 and 6. It's the sign here in between that's different, a plus and a minus. So let's see what happens when we FOIL those. So v times v is v squared. Then we have a minus 3v, then a plus 3v, and a minus 9. So these middle terms here are going to end up being 0. Negative 3v plus 3v just gives us 0v, which is 0. So this just becomes v squared minus 9. And this pattern here is called a difference of squares. It's a difference of squares. Difference because there's a minus sign here in the middle. of squares, because b is a square and 9 is a square, it's 3 squared. And so both of these terms here are squares. Let's go see this pattern holds true here. 25x squared minus 30x plus 30x minus 36. Again, we have a minus 30x and a 30x that are going to turn to 0, so we won't have any more x's, and we just have 25x squared minus 36. Here we have another difference of squares. Difference, there's a minus sign here. 25 is 5 squared, x squared is x times x, and 36 is a 6 squared. So we have another difference of squares. Go ahead and do numbers 9 and 10 on your own. Pause the video and then come back and check your answers. So here we have the answers to 9 and 10. Both of these end up being a difference of squares. Now for number 11, we want to evaluate a plus b all squared for a equals 4 and b equals 6. So we're going to go ahead and substitute. A is 4, b is 6, and then we're going to take all that and square it. Okay, so we just use the order of operations. Our order of operations, again, we have our parentheses come first. So everything inside parentheses happen first. Then we go back and do our exponents, and then we do any multiplication or division in order from left to right, and then any addition or subtraction in order from left to right. So we can go ahead and take care of what's inside of the parentheses. 4 plus 6 is going to be 10, and then 10 squared is going to be 100. Now we're going to evaluate this next expression, a squared plus b squared, again for a being 4 and b being 6. So we're going to substitute 4 in here and get 4 squared, and then we'll substitute 6 in here and we're going to get 6 squared. Now this time we don't have parentheses, so we have to take care of our exponents next. 4 squared is 16, 6 squared is 36, and then we can go ahead and add those together and get 52. So my question here is, does a plus b all squared equal to a squared plus b squared? And the answer is no, because look, we didn't get the same answers when we evaluated for a being 4 and b being 6. So this is one of those common mistakes that I see students make all the time, where they want to distribute the square inside of the parentheses, but that can't happen when we have a plus inside or a minus. Again, only products and quotients can you square everything inside. What we need to do for this problem is to go ahead and when we square a binomial is to write it out twice and FOIL. So then we get a times a is a squared, a times b is ab, b times a is ab, and b times b is b squared. So when we combine like terms here in the middle, we get a squared plus 2ab plus b squared, and that is what a plus b all squared equals.